We're working on Chapter 5 tonight, and the first part of the chapter is teaching you about the language called C#. C# is what we call a C-style language, not dissimilar from languages such as C++ or its parent language C. Also not dissimilar from working with languages like Java. Just before we began the video, I was asking the students in class what programming languages they've learned and what classes they've had, because it is very helpful to know some programming before you move forward. But at this point, we're just introducing you to a different language. Programming concepts are essentially the same. You're just learning a new syntax. You're going to see that from the syntax here, it's so similar to things that you've learned that it should be pretty quick for you to pick up. Of course, there's always nuances and tricks and I shouldn't even say tricks, but techniques that take a little bit more effort to master and learn. But if you have the fundamentals, it shouldn't take you much to just jump in and create output statements and create simple methods and do some math. And we're going to do all those things here tonight. All right, the topics for the chapter are listed here at the top. So we're going to learn some of the basic constructs of data types and variables, etc. Decision statements, of course, that would be ifs and switches and things like that. Reuse, of course, for code would be loops. So we'll learn how C# does that. Also, some techniques for organizing code. And then we're going to talk real briefly about object-oriented programming. And yes, C# is a full-blown object-oriented programming language. So any of the concepts that you've learned, let's say, in Java, I know a couple of you are in Java right now, so in fact, our lecture tonight is going to be all about objects and classes. Those concepts directly transfer, and you're going to see a lot of similarities with how we name things, what a method is, what's public and private, and getters and setters, and you'll see a lot of commonalities there. If it's your first exposure to things like object-oriented, some of the concepts will be a little bit new, but you will have classes where that topic will be covered in depth. And I'm looking at my Java people right now, so you guys will get a healthy dose of that tonight, which is good. All right. Now, I'm not here to give you a whole full-blown intro to programming course. You guys have already had that. One thing you should know about programming always is kind of the number one precept is when you're creating a computer program, really what you're doing is you're solving some sort of a problem. And, you can't really solve any problem unless you fully understand the problem. And then that helps you lead to the solution. And that technique of problem solving and getting things done, that is common across all languages and all approaches. Whether you're creating web pages or you're writing mobile apps, that technique never really goes away. Now we learned as we were working, and I'm going to go ahead and launch Visual Studio here, except I'm launching 2012. Let's do 2015. And I'm just going to have it running in the background so we can take a look at things as we're working. I am going to pull up the site that we've been toying with, for the majority of the semester here, just to show concepts as I'm talking about them. So the first thing that they talk about here in the chapter is this whole concept of how we create separate files to contain the programming code. So really what we're kind of doing is we're kind of separating the presentation of the web page from the logic of the computer program that drives it. And that you can see very clearly when you look in Solution Explorer, and you can see behind the scenes where we have a C# code file. Now this one happens to be empty. It's not really doing anything, but we can fill it with a bunch of code to do all sorts of things. Just about anything you can imagine that you can do in a computer program, you can pretty much do it right here. All right. The other thing that you'll see on some of the projects that you'll work with is you'll start to create separate folders within the project. And the one they're pointing out here in the book is very often you'll have an app code folder that's created. So depending on the project template that you choose when you first create your project, that will pre-generate some folders. Now we started basically from scratch, so none of the folders are really there, but you can still create them, and then some of those folders have special meaning, and app code is one of those. And that really is designed for a spot where you can just take straight up programming code and you throw it in there when it's not attached directly to a page. Right? The stuff that we've been doing so far is we create a page, it comes with a code file, we want to do some code on that page, we use that file. But sometimes you'll write code that you want to use all the way through the website that maybe controls a bunch of different pages or the whole application. Or it's got some little routine that does that's useful for many pages and not just one. So why would you recreate that code on every single code page? It makes no sense. So it's a centralized spot. Now, anytime that we're running a web application, and I'm back over here at Visual Studio, and we go ahead and we hit that button, a number of different things happen. When it comes to looking at a web page, you don't really need a web server to look at a web page. You guys should have learned that in Web 1, right? You just write some HTML, you throw it in a folder, you open it up and drop it into your browser and you can see it. ASP.NET is a server-side technology, and that's one thing I want to make sure that you guys are clear about, and that means that it requires a web server to run and execute the code, whether that's the C# code or ASP tags. The server has to run that first. In other words, it will either run it as a scripting language like JavaScript, that's the ASP tags, or it'll take the C# code and actually compile it, right? And compiling is a process where the code gets turned into an executable so that we can then use it in our application. So really we're kind of marrying different types of technology, and what we're in essence doing, folks, is we're stepping into the modern world because this is where the world is going. People are writing computer software, and they used to make it run inside Windows or a Mac or a Linux machine. And now what people are doing is they're writing applications, and the part that people see and interact with is the web browser. So we're kind of creating applications really that are becoming a little bit more universal. And that's a good thing, especially for us in this field, because that means obviously the web's not going away, right? Everybody uses all sorts of devices. Web applications push out to any kind of device. They don't care if it's Windows or Mac or an iPhone or Android. It doesn't care. It'll just work. So that's pretty important. But that compiled code, when we are working with C# or something like VB, it does compile. And when it compiles, it goes through that whole .NET framework that we were talking about, and then turns into something that runs on the server executes it, and it does our page stuff for us. But ultimately, what the viewer sees in the browser, they don't see any C# code. None of that stuff that gets compiled, none of those ASP tags will ever show to the user when they do right-click view source. They will never see it. And that's kind of one of the beauties of it, because they don't need to see it. Do we need to see the code behind Microsoft Word in order to use it? No. All right, let's take a look at some of the fundamentals here. In most programming books, we'll start with something like variable declarations. So that's where we are starting also. Now, this book is nice because if you did start with Visual Basic, this shows you both the Visual Basic and the C#, so you have a basis of comparison. And I think that's really cool. And it also gives you the capability, if you're interested, where you could build in both languages at the same time. And I know that one of you was talking about going to see the tutor downstairs. Was it you, Tom? And he's one of those people that when he was in my class, that's exactly what he did. Because he started asking me questions. At the time we were only using VB, and then he started asking me questions about C#. I'm like, you should be working on the VB stuff. And he's like, oh, I want to know both. And I'm like, well, that's great. That's perfect, actually. So this is kind of an opportunity to reinforce Visual Basic skills and also to realize that you can write all of this stuff with VB if you want. The reason we switched to C# is because Microsoft has switched to C#. If you take any of their official training courses, that's the language they push. They don't use VB anymore. Okay, so that's important. All right, so let's take a look here and do a comparison now between Visual Basic and C# for some of these concepts. So one of the things you first learn when writing any application on the code level is how to declare a variable and what a data type is. Now, if you look at the old-fashioned like VB approach, and I shouldn't even say old-fashioned, if you look at the Visual Basic approach, they have a very unique and quirky syntax. One that is very unique, I just said that, didn't I? But very unique to Visual Basic. It doesn't really translate to other languages aside from Basic, which makes it an oddball. So with VB, we always use this dim statement. And does anybody know what that means? It probably says it there somewhere. Declared in memory. So it's telling you it's declaring in memory something named distance in miles as an integer. And that's it. There's no closing punctuation. It all goes on one line, and it basically says we're making an integer called distance in miles. In C#, however, this is very Java-like, right? Or C-like, or JavaScript-like. So you just say int, that's the keyword, and then you give it a name. Semicolon at the end. Integers, of course, are one of your basic data types in all languages. Counting numbers, whole numbers, positive or negative. There is a limit in every programming language as to how much data any data type can hold, like how big of a number an integer can hold. And there's a table coming up, I think, in the chapter that would specify that if you're interested. The other thing they're pointing out here is how you do comments. In VB, you learn that you do a comment by putting an apostrophe at the beginning of the line. Once again, very, very oddball language quirk. In C#, you use forward slashes, a pair of them. That technique is true in, I can't even list how many languages that's true in. It's so many of them. And it also accepts C# style, or excuse me, CSS style comment marks too, with the forward slash and star, then star forward slash. And I think they show you that coming up. Let's ramp up the example a little bit. Compare the VB and the C#. So in the top example, they set an integer, and once it's declared, then they give it a value. So my analogy always for declaring a variable is I get a box, I give it a name. That box can only hold certain types of things. Sometimes I just get the box and give it a name and don't put anything in it. That would be what this first line is. And then sometimes we put stuff in it, and the way that you put something into a variable is by using the assignment statement, which is an equal sign, meaning that whatever is on the right side of that equal sign is going to be placed into whatever is on the left. That's a general rule of thumb in every programming language I can think of. I don't think there's even one exception. Notice that they also, aside from integers, are looking at strings. Strings do exist in C#. I know my Java people are probably a little surprised. String's not a primitive data type in Java. Yeah, it's a little different. Although you can still use one with a capital S. But this is C#. You can declare strings. And strings, of course, need to be inside of double quotes, regardless of the language that you're using. Another thing that they're doing is showing you here that you can do combination declarations. So in other words, you can state the data type, give it a name, and a value all at once. That's allowed. And in many circumstances, the preferred way to do it because it's one less line of code. Same for the string. Another thing they're pointing out too, and I guess I put in these highlights a while back to show how the naming convention that they recommend. what they're doing is they're typically starting it with a lowercase letter, and then anytime there's like a logical word in the structure, they start with a capital letter so you can kind of see where each word begins and ends. They call that camel case. And it's not a requirement, it's just kind of a convention that people do. What is important to note though is that case is important. So if I call this distance in miles here with a lowercase d, and then I go to the next page and use an uppercase d, they're different things. They are not the same variable. Case is critical. All right, here they start talking about the numeric data types, and you'll notice that many of these you've already heard about in other languages. Whatever language it is that you've worked with. In VB, and a lot of you have had that intro to programming class, you'll see some of the number formats that you've used often. And typically, as programmers, the ones that we're going to use most often are going to be integer, doubles, and decimals. We usually don't touch a lot of the other ones because those kind of do everything we need, for the most part. There are circumstances, though, when you're trying to write a super efficient application, and let's say you know that the numbers that you're going to be using are going to be very small in size, you could opt to use a byte because it'll take up less memory than using an integer. Because look at the capacity of an integer to store values and the capacity of a byte. And notice that's only positive. And guess what? There's a reason they call it byte. It's because it only takes 8 binary digits to get the information to generate a character from 0 to 255. 8 electronic pulses, on or off. Something like this, gosh, I don't even want to do the math on it. It uses a significantly larger amount of memory every time you put a number into it. Now, we don't worry about that so much anymore because there is a lot of automatic memory management that happens by the .NET framework underneath that we don't even see. It kind of elegantly deals with it. But the truth is, if you want to write a very efficient application, choosing data types can make a big difference. These days, we kind of tend to ignore it because our computers are fast and powerful, and they have lots of like RAM and storage, and it's not really a significant issue. Notice, the capability of some of these other ones, how long, significantly more values than an integer, and a float significantly more than a long. That's to the 38th powers. That's like add 38 more zeros to the mix times 10. All right. So in C#, the ones that we're interested with are in this column. And for the most part, they're the same names as the VB equivalents, usually starting with a lowercase letter. All right, moving on to the next page here, they have a few additional data types that still, are similar, I should say, to the VB ones. And you notice that VB's got a couple that are kind of odd. Like it actually has a date as a data type. That's kind of odd. That's not the case in C# or most languages. There is a character and a string, and those are basically very strongly related to each other, but they are unique data types. And then some additional numeric formats, and then also the capability of actually moving objects around as a data type. Now, a lot of times when we move objects around, we don't think about naming them objects when we're declaring them. We just create them as classes, and those essentially are objects too. But you can formally declare things as an object. All right. Now, when you do math, right, if I take an integer and an integer and add them together, I get an integer, right? 1 plus 1 equals 2, which is also a whole number. Well, what if I take 3 and divide it by 1 as an integer? What do I get as a result? Yeah, it actually converts to a different data type. Now, The weird thing is, if I am doing math, and depending on the kind of variable I'm pumping it into, the result, I'll get different types of outcome. And you guys are going to see this in your Java class too, Java people, that the casting can be a little bit different from language to language. In some languages, you divide numbers together that should give you a decimal answer, and you'll still get a whole number. And you have to know what the language does to really handle it correctly. So there is casting that happens, and that's what this little section is about. Another thing that's pretty important is the fact that sometimes when you are taking information that is numeric and you want to put it on the screen, it needs to be converted to a character format or a string in order to be able to display. So it's not unusual to take some things and apply a method called ToString to turn it into character so we can put it on the screen. And that's a little weird at first because maybe you've worked with JavaScript and it just works. You know, doesn't even worry about it hardly at all. But in this case, you do need to know that. There's also little routines such as this that allow you to take plain English phrases and convert them into other data types as well. That's not always the case in all languages either, just important to know. All right, this section they start talking about how things cast. And I don't know if you guys are noticing here that there's a string with a capital S here, which is the same kind of thing that we see in Java, and the same thing exists in C# as well, where we have, in Java, if you want to use a string, there's no lowercase data type with a string, because a string is actually an array of characters. But in a language like C#, you can also use string as a class. So it's, in other words, instead of it just being a data type, it's also a class that has a bunch of different methods attached to it that allow us to do string-like stuff. And some of those classes that come with it do some pretty specialized functions. So it's not unusual to see both an uppercase or lowercase, but when you're using the uppercase, it's really pulling in all that additional functionality. All right. Let's move on to arrays and collections. Now, I'm hoping that you guys have worked with arrays at least in some, capacity. Arrays are basically a way to take data and group it together with one name, but still have lots of individual pieces of data, but each with their own unique identifier. So one common thing I'll do when I teach people arrays is I'll just bring up Excel because it's kind of a nice way to kind of graphically build an array. So for example, I might create myself a variable, and let's say what do we call it? Number array. That's the name of my variable. And an array is a construct that allows for multiple items to be added to it, and those items will be available for use based upon the index value of the value. So, for example, you guys that know arrays probably get what I'm doing already. I'm just using Excel basically to kind of help me highlight this. So I kind of think of an array like this. I think of it as one named object with a number of different storage positions. In this case, there are 6 storage positions, 0 through 5. An array positions always start counting at 0. And that's an important consideration, but the array is of size 6. So if I wanted to actually access one of the values inside the array, I would refer to it by its key, or I guess maybe better yet, by some definitions, index value of the value. So for example, if I wanted to extract the number 34 out of the number array, I would create a statement that would say number array square brackets 0. And that would pull in for me this value. So if I were to write that out, right now that value holds 34. The fact that you have square brackets after a variable name is the indicator that you're working with an array. So it really is as simple as that. Once again, in VB, totally non-conventional way to do arrays. Really, this is the signifier that it's an array. Almost every other language uses square brackets. There's some that will also use curly brackets when you start to do hashes and things like that, or start to work with JSON. But square brackets are kind of the convention. You can declare an array of strings by simply saying string and then adding the square brackets after it, and that automatically implies that you're creating a new string, say the keyword new, and people in the Java class, this is called instantiating an object, so we're really instantiating an object that's an array that's holding a bunch of stuff. And we're telling it the data type, and we're telling it what size it's going to be. We're declaring in advance, we're creating a new string, and it's going to have 2 positions, 0 and 1, and that's what they're pointing out here. Doesn't mean the index value goes up to 2. They're saying 2 positions. These are 2 positions. You always have to remember that about arrays is the size is, in positions 1 less than the number you're assigning to it, because that is 2 positions. But if you're doing a count, it's the converse, right? 0, 1, that's 2 positions. You can directly populate data into an array by just simply array name, the index value, and the value you're putting in there. With the example that they were giving, where only 2 array positions exist, 0 and 1, if I try to put this into position 2, it doesn't exist. So for example, if my array was only this big, and I'm trying to put something into position 2, well, there is no position 2 in the example in the book. In our case, if I try to put something into position 6, it wouldn't work. All right. Yeah, this is kind of an interesting little quirk. You may have learned this in Visual Basic. Like if you wanted to change the size of the array, you could run this really weird redim statement, which resizes the array. C# does not have a direct way for doing it. You actually have to run what they call a method called resize, and it's part of the array class that will change the size of the array for you. So it's not that it's not possible, it's just done a different way. But yes, that can be done. All right. Working up from arrays, we go to collections. And collections are interesting in that they allow you to store more than just simple variables. They allow you to store objects within them. And that can be a very powerful thing because an object can have a whole bunch of things attached to it. So it's kind of a way to logically organize a complex collection of data, and that's one of the reasons why they call it a collection. All right, so collections in this and other similar languages are often called array lists, and it behaves essentially just like the array, but notice that we're not using the square brackets here. It's assumed because it's an array list that it already is in that state, and then we start creating it, and then we just use methods to manipulate the data inside. Right. They go through a little bit of a rigmarole there about weakly type collections, very simply meaning when you're mixing data types within it, because you can do that. But there's reasons why you would or would not. All right, next little topic here, this is kind of an interesting one, is a concept called generics. And it says here, generics are to code what Microsoft Word templates are to word processing. In other words, you kind of get a structure to work with in which you can put in your own information, but it has a structure already. And that can be very useful. And once again, we'll get something that is basically like an array list, but in this case, notice the HTML style brackets around it. So we create a list, and then we declare a data type, and then once again we have the parentheses at the end in order to do the manipulations of the content within the structure. All right, and they go through and they give some examples of that, and I'm not too concerned about that. So let's move on to statements. Now, you guys have already been using statements in your programs, and that is where you write one little line of code, and then it's terminated with a semicolon. And statements, as you know, are the instructions for the program. So you tell the program, do this, and each one of those things is a statement. There's a number of different types of mechanisms that we can use to facilitate statements, because statements can take many forms. Depends on what you're trying to do with the code. One of the most basic things that you do is assign values to variables. And you can see that the equal sign is our basic assignment operator. It's true for VB and it's true for C#. If you see a spot where there's a double equal sign or a triple equal sign, that is a different meaning. That's for comparison. A single equal sign means that the thing on the left is receiving the value on the right. Remember that rule. Works for all languages. There are also operators that we use for doing math, and these aren't all that weird. But you'll see that VB, once again, has a couple of weird ones in the mix. Most notably, the integer division and the fact that you can do powers with the caret symbol. C# does not have those capabilities. And it's not a mistake. They have math libraries that do that work, or you have other mathematical techniques that you can leverage to do it. Modulus in C#, that's really the only one that's different. That's the percent sign, and I think we already looked a little bit at that, or at least talked about it a little. And if not, well, I'm not recollecting it properly then. All right, let's take a look at some real basic math operations here. So for example, they set up an int, a float, and a double. They give a value to each one. And then they start doing some math. So that's addition, subtraction, multiplication, and division. And they show you what the results would be. And I'm making the assumption you guys have learned all this stuff in other classes, so I'm not going to do examples. I hope that's okay. Here they show how they do powers in VB and how you would do powers in C#. And this approach, frankly, is the more common approach in most languages as well. Of course, if you're just squaring something, it's 3 times 3, right? But if you're doing something to like the 23rd power, you don't want to do 3 times 3 times 3. You don't want to do that. So then the syntax here becomes very useful. Here's an example of modulus, right? That's remainder division. So how many times does 3 go into 17? 5. How much is left over? 2. That's what modulus is. All right. Here they show the order of operations, and you guys should know this as well. Does anybody have a clever acronym for it? For the order of operations? Say that again? Yeah, please excuse my dear Aunt Sally. Yeah. So that just simply means that you would do parentheses first, exponents, what else? Multiplication, division, addition, subtract. Yeah, there you go. All right, but here's all the different operators and the order in which they have precedence. We also have these kind of like these shortcut operators that we use. And if you guys are familiar with this from other languages as well, where this statement here is equivalent to us saying some number equals those two statements are functionally equivalent. So what they're saying is we're adding these two things together, but do I have to say them both twice? That's really kind of the syntax there. And that does transfer to subtraction, multiplication, and division as well. And, you know, I usually don't see a lot of people doing these approaches, but certainly the top two quite a bit. There's also the plus plus operator that we see in a lot of C-style languages, and that's what we call an increment. So when you see a variable plus plus, that means we're adding 1 to it. If you see something with a minus minus, that means we're subtracting 1 from it. Simple as that. So somebody just thought it's a little bit easier to do that than to write out some long equation. Moving on to the comparison operators. These are the operators that we use to test logic. So they become very important when we start to do things like if statements or loops, and we need to check a condition before a piece of code executes. Once again, look at the comparisons, and notice how I highlight in VB some real oddities. Because in VB, I can do a comparison with a single equal sign. That doesn't happen in other languages, folks. So be very wary of that. In C#, it requires 2 equal signs. So if you write a statement like if pay rate equal 100 is different than pay rate equal 100, that wouldn't work in C#. In VB, it would. Also be mindful of what not equals is in C#. Huge oddball VB uses 2 brackets next to each other. I know of no other language that does that. Much more common what C# does, which is an exclamation point preceding an equal sign. That means not equal. And that's a very important one to know. Greater than, less than, with the equal to's attached, and there's also is. And is kind of an interesting one because it allows you to basically look at a couple different things and see basically if something is something else. So for example, like 45 is a number, or is something else, or an integer, something like that. It gives you a bunch of different ways to do comparisons. All right. Here they're using, this is kind of interesting because this is actually incorrect syntax right here, and I don't know if that's by intent or not. Okay, and I'm actually reading the text above it. You see what it says? If I ran this in C#, it wouldn't work. This requires a double equal sign to work. In VB, that would work. All right. So we really want to have something that looks more like this. Anywhere that we would test a condition for code. So that would be if statements, loops, switch statements, things like that. So that's pretty important. Another thing that you might see is when you have numbers pitted against each other, variables like this, and these are not checking for value, these are checking for true, false. Is 4 greater than 5? False. Is 4 not equal to 5? True. Is 5 greater than or equal to 4? True. Right? And you guys already should know this stuff. Now, of course, when we're working with that is tool, or I guess what would you call it, comparison operator, it says if my text box is a text box, so you see how that works? It makes complete sense. And here in VB they use type of. Once again, that's kind of, I'm not going to say it's a complete anomaly, but it's a little bit different. Some languages will use syntax similar to this, and some will use syntax like this. Concatenation in VB, another oddball with the ampersand. C# is a plus sign. That's very common amongst most languages too. Concatenation, of course, is when you're not adding numbers together. What you're doing is you are taking strings of characters and stitching them together. There's also some logical operators that you can throw into the mix. And these are all the basics once again. The ones that you'll use most often will be and, or, and not. Notice in C# the difference with VB. With VB, you spell stuff out. In C# you do not. And I want my Java people to be really careful here, because Java, we do it the same way as what you're seeing up here on the screen. But we have also these combinations which are kind of interesting, because really what they are is what we call short circuit logic. What that means, right, is if I'm doing comparisons, right, if I'm saying this needs to be true or this needs to be true for something to run, how many things need to be true for it to run? One. Either this or that. Right? So if I check the first thing and it's false, I move on to the second thing and check it to make sure that one's not true. I only need one to be true. Right? But if I check the first one and it's not true, well, I better check the second one. If that one's false too, then it's not going to run. If the first one happens to be true, I don't need to check any further. Right? Because I only need one to be true. I can stop right there. That's called the short circuit. So very often what you're going to see a lot of programmers do, this is true in Java as well, is they'll just go with the double ones. With the and one, it doesn't really make as much sense though, frankly, right? Because in the and condition, both have to be true, right? So there really kind of is no short circuit, but what they're doing is they're allowing that in, because in other languages, the only way you can do an and or an or is with a double ampersand. And what I find a lot of people who like learn Java or C++ first is what they'll do is they'll come in and they'll just stick with the double ampersand. And it works just the same. So either way, single or double, that will work. So they go through examples here. But notice like these combination statements, right? So really we're checking two conditions of truth, right? Does num1 equal 2? And does num2 equal 7? Both conditions would have to be true in that case. If this was changed to pipes, that vertical straight up and down line, only one of them needs to be true. This is programming logic that you guys should firmly have your heads around at this point. All right, in addition, another real important programming construct is the ability to make decisions. And in programming languages, we usually start with if and if-else statements. And basically what we do in that situation is we we create the if statement, and then we check for a condition to be true or false. And then given the satisfaction of that statement, if it was true, we would execute what's inside the if statement. You guys should know that already. The other thing that you might choose to do is, if something is true, do this. If it's not, you're not going to do it, right? Then you move on, check for a different condition. If it's true, you do it. If not, you don't. But that often leads much better to do an if-else statement, especially if they're just opposite conditions. If they're opposite conditions, there's no reason to write extra code. You just do an if-else, especially if you need it to be one way or the other. Okay. So if this is true, do that. Otherwise, do this. The else is not obligatory. You also have the capability of checking multiple conditions. Well, is this the case? Nope. Is this the case? Nope. Is this the case? Yes, and then you do this one. Now, when you start to get multiple else-if statements where you're checking different levels of items that are true or false, then sometimes it makes sense to switch to what we call a select case or switch statement. This is how you do it in VB. You should have learned that. In C#, which is more like other languages, you set up a switch statement and you set up a case. You pass in a certain value, and if a value has a match to one particular item, then you will execute the code statements that are inside that case. Be very mindful of the fact that when you do switch case statements that you put a break in each case, because otherwise it'll keep checking. So the other thing that you have in these is the ability to have like a default. So if none of the conditions catch, then the last one would execute. The default is not obligatory. So that's a switch. All right, folks, that ends the lecture portion of this chapter. We're going to take a break here in class. We're going to come back and code.